practice it, we can do that. I don't think 12 factorial should be tricky for you, but some of these might be. All right, so we are on our pretest, and the answer to G, 1G, is 12 factorial. What's the answer to 1H? 11 factorial. One less in a circle. Good. How many ways can the members of the team be arranged in a row if the boys must be kept together? The boys are being kept together. So what will that be? 9 factorial, 4 factorial.
Which number is that?
Why 9? There are 8 girls and a bunch of boys, one group of boys, and then there are 4 of those in that group. That was letter I. Now we're ready for J. The boys must be together and the girls must be together. 2 factorial, 4 factorial, 8 factorial. Where did the 2 factorial come from? 2 groups. Where are you going? Okay, all right. 2 groups, right? Okay. Number 2. You are to choose 5 cards from a standard deck. What is the probability? What is the probability that you will choose at least 1 king? Oh, we need to talk about this. We talked about this before, but we need to talk about this. What does at least 1 king mean?
It means 1, 2,
1,
3,
or
4.
2, or 3, or 4. Please don't say 5 kings. It's 1, 2, 3, or 4. Now, could we do that?
Yes.
Yes, but that's a lot. It's doable, it's a lot. What I want you to think about is this. If I deal you a 5-card hand, could you get 1 king?
Yes.
Yes. Could you get 2?
Yes.
3?
Yes.
4?
Yes.
Is there anything else that could happen?
No.
Yes, there is.
The Joker.
You could get no kings. You can't get 5 kings, okay, before you clarify that. You could get no kings though, right? You could get none. So instead of doing all those individual cases, what if we took 1, which is 100%, and subtracted the probability of no kings? Now think about that for a minute. If you took out all of the hands that have no kings, what would be left?
48 C5.
Hands that have kings? Right? If you take out all the hands with no kings, what would be left is hands that have kings, right? So here we go. 1 minus. What's the probability of a 5-card hand with no kings?
48 C5.
48 C5. Why 48?
Because 4 minus.
There are 48 cards in the deck that are not kings.
Yeah.
Divided by
52
C5. When you approach a problem like this that has multiple options, you can either work out each option and add them up, or you can do the total 100% minus the options you don't want. This is easier in this case because there's so many other ones, so many other options. Okay? Okay, here we go. What is the probability you will choose all red? It's still a 5-card hand. We want all red. 26 C5 divided by 52 C5. Let's see if we can finish this section, and then I'll let you run out into the world. What is the probability that you will choose exactly 2 black cards? 26 C2 times 26C3. Now what's that?
It's the 2 black cards
Two
times
blacks
the rest of the cards.
and 3 reds. That's what has to happen. It is a probability question, so we're going to divide it by
52C5.
D is not probability, okay? D is how many hands. How many hands are possible in the deck? You've been using it in every problem. 52C5. That's how many hands are possible. It's a big number. I think we've done this one before. How many different hands are possible if all the cards must be of the same suit?
So, yeah, 13C5.
Well, what would 13C5 be?
Be 1 suit. And you have to
That would
multiply
be
it by
5
4.
hearts.
You have to multiply it by 4.
What would 5 diamonds look like?
13C5.
Same thing?
Yeah.
And clubs and spades? So we have 4 of those added up because it's hearts or clubs or spades or diamonds. So you could add it up 4 times, or it'd be easier, just multiply it by 4. How many different hands are possible if 3 of the cards are of one suit and the other 2 are of the other suit? In other words, an example would be 2 diamonds and 3 clubs. Let's do that example. What would 2 diamonds and 3 clubs look like?
13C3 times 13C2.
13C2 times 13C3. All right, now wait a second. Is that going to be the setup for all of our examples? So we need to think about how many examples there are.
Times 4P2.
Times what?
4P2.
Yes, very good. Trey, you need to explain that to us. Why did you multiply by 4P2?
Because there's 4 different suits and you're picking 2.
And the order you pick them matters because you're taking 2 of one and 3 of the other. So that's 4P2. Nicely done.
I like it.
Alex, would you turn that off?
Yeah, we done
Thank
for
you.
today?
All right.